Hi, this is Dr. Paul Feuerstein, Technology Editor of Dentistry Today. And I'm here with Skip Abbott. Skip, how you doing?
I'm fine, thanks, Dr. Paul.
And Skip is going to tell me about something I don't know much about yet, but we will by the time we're finished with this. We're talking about posts. And in my career, we've used stainless steel posts, we've used screw-in posts, we've used titanium posts, we've used fiber posts. And sometimes there are some issues about uncured cement, unset cement, and I think you have a little solution here. What's the name of the product?
It's an Ilumi dental post. It's a little bit unusual from typical fiber posts because it's made out of a optical glass fiber as opposed to fiberglass.
Oh,
so
do they run the length of the post?
The fibers run the length of the post.
They're already.
Yeah, exactly. So it's similar to a fiberglass post in that way, but the thing that makes it unusual is that it is an optical fiberglass, which means that each one of those little fibers is coated with a cladding, and that cladding allows full reflection of the light down the entirety of the length of the post.
And laterally?
And laterally.
Uh-huh.
These posts are designed a little bit oversized, and then they're polished to size. In that polishing process, it opens up
those little the ends of those little fibers.
Exactly.
I see.
Yes.
So if I cement one of these posts in, I'm using say a dual cure cement or a strictly light cured cement. I just shoot the light on the top of the post and it transmits all the way down to the bottom of the tooth?
Exactly right. You can use either the dual cure or the light cure.
Mm-hmm.
One of the advantages to the post, in fact probably the main advantage, is that because you can use just light cure and you can be confident that you're curing all the way down the entirety of the post, 30 or 40 seconds with your light and you're done.
But with glass, is it radiopaque at all?
It's totally radiopaque.
Okay.
Ours has a radiopacity that's about 5 times that of aluminum.
Wow.
And so it shows up very clearly on x-rays.
So I can see the interface very clearly.
Yes.
Now, as a typical fiber post, the reason that we've gone to some fiber posts versus steel posts, there's some elasticity to these things. What about this post?
Well, the nice thing about fiber posts is that they have a modulus of elasticity that's basically equal to dentin. So whereas steel or titanium is very hard, and if you bite onto something with a titanium post in there, you can crack the root.
Exactly.
This gives a little bit, as dentin would, and so it acts like the tooth material and flexes just a little bit.
Well, in essence, you're reconstructing the entire pulp chamber and the canal system and making it one continuous piece.
It's one continuous piece.
So that's actually stronger than we started out with before it needed the root canal.
I think it may be.
Wow. So I have a little kit in my hands. It shows a couple of drills and some different sizes, I assume. So how does the whole kit work and how does that operate?
Well, for the drill bit is contoured the same way that the posts are. The posts are tapered on the ends,
right,
and the drill has a taper that matches that. The drill is oversized to allow for cement.
Okay, that's what I was going to ask you next.
Yeah.
So you have enough room for the cement.
Yes.
So you have this solid resin cement, bonded to the inside of the tooth.
Yes.
And this core,
and
which
bonded
is bonded
to the post.
To the post. You have one continuum right through there.
Yeah, exactly.
Boy.
So it makes, because it then becomes a composite, it's very, very strong.
So that takes care of a lot of the shortcomings of the previous fiber posts.
Yes.
That's unbelievable.
Well, you see, with the manufacture of glass,
mm-hmm,
glass has different components inside of it that it's made of. And when you're making glass for posts, you can make glass that is either radiopaque or that transmits light.
Okay.
So some glass is very, very good, not as good as our glass at transmitting light, but fairly good at transmitting light.
But this is going to allow me to, because it's a continuous fiber, I'm going all the way to the apex, or not the apex of the tooth, but to the bottom
all the way to the bottom of the tooth.
Hole.
But this glass allows for both the transmission of light, very intense transmission of light, and also some radio opacity, so it shows up on radiographic imaging, unlike typical glass fiber, which doesn't show up as well.
Since it's new to me, where would I get more information about this?
You can go to our website, which is www.ilumisi.com.
Oh, SI like science, except SI.
Yes, SI, yep. The letters S and I, ilumisi.com.
That's important to know. We want to make sure we get to the right place.
Yes, absolutely. You can find us on the web, and we're located in Chantilly, Virginia.
Oh.
The product is made here in the United States.
That's great.
Yeah.
Well, thanks so much.
Oh, it's a great pleasure.
Terrific.
Thank you.
Thanks for that information.
Oh, my pleasure. Thank you.